I'd like to welcome everyone to this webinar, Cloud Databases, Modern Properties, Classic Concepts. My name is Andrew Brust with GigaOM, and officially welcoming you, and also welcoming and thanking Cockroach Labs, who is our sponsor, appropriately given the topic. Of course, cloud databases sounds like it's a single category, but really it's not. It's not a monolith. There are important distinctions to be made, and hopefully we can tease some of those out. And also hopefully acknowledge that, the mode that we're all working in right now with the pandemic means that people are doing things more distantly and more remotely, and that changes some of the paradigms and modalities for how databases ought to function and what they need to do and do well. I don't want to give away more than that on the first slide, but I would like to introduce myself and our esteemed guest. I'm Andrew Brust. I'm a lead analyst at GigaOM, focused on data and analytics and BI and AI. I focus on that same space for ZDNet. On the journalism side, I've been in the data world really since the 80s, and in the analytics world really since perhaps, the very, very late 90s. Well, that's enough about me. Our guest is Jim Walker. Jim is the Vice President of Product Marketing at Cockroach Labs. And Jim, what I'm hopeful is, beyond name, rank, and serial number there, you could give us a little context about, what being VP of Product Marketing at Cockroach entails on a day-to-day, and perhaps you could share some of the things you did prior to Cockroach and how that informs your database worldview, as it were.
You bet, Andrew. And first and foremost, thanks for having me. I'm always excited to have a chat with some smart people about the data space, and I think you qualify as one of them. That's for sure. So, a little bit about me. Yeah, I'm Vice President of Product Marketing at Cockroach Labs. I am. I'm a data enthusiast, I guess, and I have been my whole life. I'm of the TI-99 era of computer people, and I was a computer engineering undergrad. I ended up in marketing because I like data and I like to explain these things. And ultimately, I feel like product marketing was my natural place, because I think that ultimately product marketers are translators. They translate deep tech into English, I guess. Sometimes it's not like Portuguese to English, but it's tech to English, right? And so that's what I do in my day-to-day life. I've been lucky to join some really great teams of people in my career. I love open source and have focused, definitely on open source. I've bobbed up and down the application stack, either from just straight up applications all the way down in infrastructure. I worked at a company called Talent, which is open source data integration, data quality, master data management. If people remember Initiate Systems, I was there as well back in the mid 2000s. But then I think one of the biggest experiences I had, and I think kind of the foundation of a lot of the conversation we might have right now, Andrew, is my experience at Hortonworks, which really helped drive Hadoop and big data. And we saw a revolution happen at the early part of last decade. And that was a whole lot of fun to be on the front line of that and see kind of this massive change in terms of the way that people thought about databases, from being kind of these monolithic, systems to kind of these broad geographically dispersed or, distributed type kind of systems. But from there, I was in infrastructure for a while. I worked at a company called CoreOS. I dove down into Kubernetes, but I got entrenched in distributed systems. And naturally, the combination of distributed systems and data really led me to Cockroach Labs, because I feel like this is kind of for me, a cloud database is kind of what the future is all about, and I just feel what we're doing here is extremely interesting. And so, when I was asked to join this team, I jumped, and I'm excited to be here and to talk about cloud databases with you.
Awesome. And actually, although I was feigning ignorance there about some of your history, I kind of entered the world of big data. It's a little scary, but it's almost 10 years ago. Coming from an enterprise BI background, and you're actually one of the first people I met back then. And I came in with a lot of skepticism. And you were, I don't know if you know this, but you were one of my unwitting mentors through this different world, and helping to understand it in terms of the world that I came from. So,
I remember your skepticism.
Hmm.
Let's just say, but it's been a fun 10 years though. I mean, I mean, there's this been massive changes to the way that everybody thinks about data, and it's actually accelerating, which is kind of fun right now. So
Yeah,
I don't know, it's just a whole
indeed.
bunch of stuff happening.
And then
Yeah.
by the way, I'm glad you mentioned what 8-bit computer you worked with, because that's that's becoming a bit of a thing here for my guests. So I was a Commodore 64 guy. Good to know you were a TI 99
Yeah, yeah.
A guy. Let's move on from our reminiscing here, though, and talk about what it is we're going to discuss. Our table of contents here basically is to explore a little further this idea of the current era that we're in. Even if it's contrived and hopefully rather temporary, it has still opened our eyes to requirements that will be timeless. And I think we're more sensitive, number one, and more comfortable, number two, with these new ways of working. But that also means we really need to kind of look at how well equipped we are to deal with it. And I would argue most companies actually are not. Again, this idea of cloud databases is not one thing. It's a bunch of things. And we'll talk about that and also talk about globally distributed databases more specifically. It's also important, especially given the title of this webinar, that we acknowledge that those databases that I came from before I even met you still exist, still work really well. But the question is, how easy, how frugal can you be to repurpose them for some of these new deployment patterns? And so we'll want to talk about that. We'll finish up with the discussion not just of operational database workloads on cloud databases, but analytics workloads as well. We'll have a couple of polls throughout this webinar. That is our shamelessly selfish way of getting to know the audience, because the audience is all on mute, but we do have a live audience. We would like to understand where they're coming from. Likewise, we're very happy to take questions. You'll be able to, as soon as you'd like, punch in questions into the GoToWebinar console. Those will get kind of traffic copped and sent over to us. And my style is to try and integrate those into the conversation as we go along to the extent possible. If we get really stuck in one place, then I'll just be non-democratic, Jim, and say now let's move on. But we'll try and catch up at the end in that particular situation. So let's get rolling here, and let's talk about this idea of a new landscape and requirements, but also dividends that come out of these requirements, as the blue subtitle would say. Certainly what we start out with here is this idea that there's more happening online than maybe there was a couple of months ago. And there's some things that are emblematic of that, including video conferencing software and a bunch of other things. But could you share with the audience your own observations about what new business requirements this has brought about, number one, and number two, and I think that last bullet is maybe a little leading, so feel free to question the premise, but are
Sure.
you seeing companies that maybe self-identified as mostly having a domestic customer base as perhaps now acquiring more of an image and a reality of being more global?
Yeah, so I mean, this is a really broad set of kind of concepts to talk about, but I mean, all of them are really kind of centered around this whole transformation that's happening. And for me to kind of really address like the current kind of climate of what's going on with all of us being indoors and this increase in digital presence across lots of organizations, and what I'm seeing and what we're seeing is really kind of feast or famine with many of our customers and with organizations that we're talking to. I would be remiss not to go back a couple years though, because I think this transformation, this move towards being digital, that term digital transformation is kind of one of these things that I've always bristled a little bit at it. It kind of sounds like a marketing kind of sales thing. But there's a reality to this in that,
Said the VP
well,
of marketing. Yes, go ahead.
well,
That's why
hey,
we like you.
we got to be, thanks, dude. You got to be genuine and authentic. And like, yeah, it just sounds like a digital transformation is such a, like a generic way of saying like a whole lot of stuff is going on. But in reality, what that equates to is that, we look at data in different ways, like, and we've been doing that for 10 years, but like, the shift to the cloud and what that means for OpEx and CapEx to our bottom line, has been a huge, massive impact in organizations. I mean, we don't have, I was at a company a while ago, Andrew. We had a server room, and it's funny, there was a bunch of racks in there. We didn't have servers in there. We had already moved to the cloud. And I remember we actually ripped out the servers, or the shells of the servers, the racks themselves, and we turned it into a video conference room, and it was awesome, right? And like, but that's happened all over the place, and that shift has happened. But that's like this shift to the cloud. But then there's also been this move to distributed systems, and I was very lucky to be involved in the Kubernetes community over the past couple of years, and man, I'm excited about it. Like, I was excited about Hadoop back in the early part of last decade, and then like the Kubernetes thing happened. I got super excited because it represents a change in the way that we think about systems. And I think this move and this shift to the cloud, it's still early. This transformation is still early, and I think there's a lot of workloads that haven't gone to the cloud yet because the tools and the technology that you need to basically trust these things are just not there yet. But I think a lot of net new stuff is going. Now, if you take all that change that's happening, it's like transformational change in the way we build, the way we deploy, like think about the whole concepts of CI/CD and feature flagging and like, treating infrastructure as code, like what the HashiCorp and the Terraforms, or, the HashiCorp and some of these companies are doing it, like this whole new way. Like, there's this massive transformation that's happening, bottoms up in the IT department, and then business is changing because of the costs and what's happening and the shrinking globe and all these things. And then you fast forward to today, and what I feel like is the pandemic is a metaphorical comet that hit the planet, and like, man, that's just disrupting a whole bunch of stuff, and it's almost accelerating this. I hate to say it, it's accelerating this digital transformation. And I think it's, to just talk about what's happening right now out of context of what's been going on, it's not fair, really. But I think from a business point of view, come back to like your original question, is that yes, it is absolutely having an indelible effect on lots of organizations. And what we're seeing is kind of this feast or famine, where business is drying up for certain organizations. If you look in travel and some of these other places, this is difficult times. If you just look at kind of the headlines in the Wall Street Journal, but like, we're seeing other organizations that we're digital first. This massive, huge increase and new challenges for them. I mean, we're seeing companies that we just think know how to deal with this large scale web applications. Like, they're struggling to meet the performance needs, or they're struggling to meet the scale and the demand of those applications. And so, I'm seeing lots of different things, but I think ultimately it comes down to there's this, like, there is a mix of feast or famine going on out there. It was a bit of a long-winded answer, but it's about make sense.
It does, but I still want to redirect you to my follow-up. Are you seeing customers or the profile of your customers becoming more global, or is that just, I don't know, is that just me over forecasting here, maybe in the slides?
Yeah, it's a little bit of both, maybe. I mean, I think,
Fair enough.
I think, if you start a business today, you may think in a very local way, or maybe very domestic, if you will. But your customers, ultimately, if you go digital, ultimately are global. Like, do people design systems to be global from day one? Not always, but have you at least, removed the risk of not being able to become global in the way that you design things? And we are seeing people do that today, for sure. And so, I think, is there a push to more, global services for people? Yeah, that's happening. And I think this, this change that we're going through right now is definitely pushing people to think differently. I mean, my own personal life, I'm on the phone with people all over the planet all the time now. I'm not even sure what time zone people are in, because all of our meetings have turned into digital, right? And so, what's the long-term effect of that? Should be interesting.
Probably that we're sitting down more, but beyond that, yeah, it's interesting. It just seems like if you tool up to be able to take on your domestic online audience and customer base more, than the silver lining there is that you're also tooling to be able to handle customers from anywhere. That's the whole point of scaling, right? Is that you can scale, right? You're dealing with a new requirement, but on the other hand, you're getting future ready for requirements that haven't come in yet. You don't have to be scared of them. Now let's talk about cloud databases, because I think for everybody, you think of cloud database and something pops into your head, and I think it's different for different people, right? It could be one of the I hope it's okay if I mention a competitor's name. Like it could be DynamoDB on Amazon. Maybe that ends up being a a bit of an archetype for people. Or maybe it's just this notion of running your old RDBMS, your old relational database system, but not running it in the server room, which, by the way, when you said the server room had racks, maybe because you're from Cockroach Labs, I thought you said rats, R-A-T-S. But,
no.
I'm glad to hear that wasn't the case, especially with the New York office. Anything's possible, right? But
that company was in beautiful San Mateo, not in Manhattan.
There you go. Okay. But anyway, we've listed some things here that, depending on who you're asking, maybe these are the things that, these are the stereotype attributes that pop into their head. Which of these, if any, is necessarily the case all the time? And I don't know, which ones don't matter, or or tell me anything interesting you have to say about any of these that jump at you.
I mean, if we dissect it down, like if I dissect a cloud database down into its like most core constituent components, right? I think number one, the word cloud is overloaded in many words, in many ways. I think you and I can define a database, and I think we can all define what a database is going to do. It has to actually collect data and store it, and shouldn't lose data, and it should be correct. That's what applications mean. The cloud, to me, it's largely changed our consumption models and the way that we think about consuming models. So when we think about like this utility pricing, it's a big deal, right? We never thought about, being billed by the minute or by the hour or by the day or by the month, right? Like, I don't know, it's kind of a new thing over the past couple of years. And so how do you do that? How do you do that with a piece of software that's part of your infrastructure, and still make it like reasonable for people? But the cloud also means, effortless scale. I think that's what people want from the cloud. They want the elastic nature of the cloud. I mean, that's the promise. I don't need to go out and buy servers and have a relationship with Dell and HP. It was, I don't have to go out and all that stuff is going to be taken care of from just a pure hardware point of view, but it's also going to be managed. And I remember when people first started moving to the cloud, it was one of these things was like, oh my God, what about security? And I think we've all learned that actually having a central point and having, the cloud provider actually take care of things like that can actually get stronger, right? Because the best practices are focused on a way of actually doing it in the right way. And it's not like, or it's less risky, I guess. And so I think there's just certain benefits of the cloud where it's like, yes, this managed service becomes really important. But when I combine the two words together, cloud and database together, I don't think just moving a legacy technology and running it in a single server in the cloud is truly like a cloud database. Maybe I'm a little pedantic, but I just kind of put the two words together. Like running something in the cloud doesn't mean it is that thing. Cloud database to me is, how do you take advantage of everything I just talked about for that particular solution? I mean, it could be cloud CRM for that matter. And to me, that's about re-architecting. It's about, looking at the core concepts in a database and thinking through, to me, a database has three layers. There's a language in which people actually interact with that. It's like the interface, the API, if you want to call it. To me, that's SQL, whatever. I think that's just part and parcel of a database. And at the very bottom layer is storage. Like ultimately data gets stored to disk, right? Like that's just go back way back in time, and that's the whole point here. It's bits and bytes, right? But in between is this execution layer, and how we execute transactions within a database. All databases are not equal, especially when it comes to taking advantage of, scale out infrastructure, what you have in the cloud. And so, if we're just going to basically put lipstick on something and say, hey, look, I'm going to run 2 instances of this thing, and I'm going to have this shim, which basically manages, how things are kind of using it. That's not actually taking advantage of the underlying infrastructure. I think, yeah, I'm happy to talk about the approach of some of the others, Andrew. I mean, you talked about Dynamo and stuff. I think one of the biggest companies that I've seen who has really taken a really interesting approach on this is Microsoft. I mean, like Microsoft has SQL Server, and SQL Server is an amazing database. Like, think about where they were behind DB2, behind Oracle, and they caught up. It's awesome, right? And they understand developers, they understand community. They built a database that was just solid and it was ultimately fantastic, right? And integrated with Visual Studio, and they did a lot of things right. And that thing's great. But you know what they did? They went out and actually built Cosmos. Why? Because they saw the oncoming change. They didn't say let's rest on SQL Server and just use this thing and make it work in this new environment. They said, no, let's re-architect. And I think that re-architecting, that's what's important. And to me, that's what's important from a cloud database point of view. And I mean, that's why I'm at Cockroach, because I just feel like, you can't just take Postgres and put distributed storage under it like some others have done. That's not taking advantage truly of distributed transactions, which I think that's where things get really interesting.
Interesting. And I don't know if you were just ingratiating yourself to your kind host here, but the SQL Server is the database I grew up on, and I started using it, in the early 90s when everyone laughed at it. So yeah, I'm with you to see how Microsoft came from being a laughing stock to being dominant. Of course, that happened with other products, including the, Exchange, for example, which runs lots and lots of email. It eventually overtook Lotus Notes and a bunch of other things. But the interesting thing about Cosmos is it wasn't just Microsoft sort of being, I don't know, intellectually open. It was that Cosmos started as something they built for themselves to run their own massive cloud scale services. So it's not just that they're being progressive, it's that they saw the need directly because it was their need. And then they said, let's productize this because that's the way things are going.
And that's right. And that's what Google did with Spanner. It's the same thing, right? They had Bigtable, they're trying to run things on Bigtable, but they didn't have, transactional guarantees or, consistency guarantees globally. And they said, well, in the way that Google does things, they're like, well, let's just create something new. And they do that for a lot of things, I think. But they created Spanner, and all power to them. And I give a big nod to Spanner, because a lot of the concepts that we have in Cockroach are directly related and directly derivative of what was in that Spanner white paper. From using distributed protocols, right down to the entire architecture, but not being tied to a Google data center. I mean, this for us, Cockroach, it's the same premise, but how do I do this for everybody? And I think Microsoft did the same thing, and they realized it out of necessity, not out of vision, right? And I think that's what we're seeing. We're seeing these companies that have scaled to global coverage, who have witnessed the challenges that these massive systems and kind of this new infrastructure actually present, and they've evolved. And how do we, at Cockroach, it's how do we help everybody evolve and move up that scale and complexity curve so they can all have this kind of, the same sort of, infrastructure, be it, Kubernetes, which it seems to be widely being adopted for the compute and the orchestration layer. For us, it's the database layer of that stack, and but how do I make this available to everybody to run on every cloud and actually across and in multiple clouds? And that's where things get really interesting.
And give me a browser interface to spin up the infrastructure necessary to do it. That was the thing that kind of knocked me out the first time I saw Cosmos DB actually
Yeah,
was that, because I came from the era of when I just wanted to get one server up and running. I had to deal with a grumpy IT guy to get the server racked, not ratted, but racked.
right.
And now, I mean, to me, one of the greatest things about the cloud is it's an abstraction layer over IT. I
Right.
can, there's a lot I can do by myself. There's a lot I'm empowered to do that unless I really, really bribe somebody, I couldn't even get stuff up and running for proof of concept. Now I can do it for production. And so, yeah, that's a huge thing.
And I
Go
think
ahead.
that's a generational shift that we're going through as well. Like, when you and I came up, people don't even know what that is anymore. Like that's like people expect that now. And I think that's like this consumerization of IT, both internally and sort inside organizations. It's such a big thing. I mean, for us, it's like, yeah, how do I make that easy? Not just to spin up nodes in Azure, but I want to spin up nodes in GCP and AWS as well, and have a
Right.
single database that spans all those. Like for us, we take it to a wholly other level because it's, that abstraction layer is just absolutely critical.
Yeah, it's liberating. It's and inspiring too, even
Mm-hmm.
at times where we can't go outside. I mean, there's so much
Yeah.
we can do. Can you imagine if this happened 10 years ago? What the
Oh.
heck would we have done? Anyway, I'll
You,
stop. I'll stop being a pop, industry psychologist watcher. Let's get to our first poll here, so we can hear from the audience. And this is a pretty simple one. We just want to know what types of databases you're running. And technically, I suppose one of these is not a database per se. Maybe data repositories would have been more academically correct. Doesn't sound as good though. So, are you running OLTP relational? Are you running NoSQL? Are you running a data warehouse? Are you running a data lake? And by the way, in each of those cases, that could be on-prem or in the cloud. We're not being picky about that. And what about this class of database we were just talking about, the cloud native, geo-distributed, globally distributed database? All that apply. These answers will add up to more than 100%. And we'll wait for folks to kind of register their votes. Pardon me. I'm getting so excited I'm losing my voice. But gosh, there were some other things in my head and they flew right out, right at the time where they'd be super useful. But oh yeah, I remember one of the things you said was it was interesting that you're at a company that's drawing so much from a Google white paper, and I guess that's not, or academic paper, that's not the first time, right? I mean, Hortonworks kind of did that with all their Hadoop work, right? Didn't all of that come out of Google's paper on MapReduce?
well, yeah.
So this is a
Again,
habit for you.
well, a little bit, but it's there's certain companies that go through this vortex a little bit prior to everybody else, and
Mm-hmm.
for me to predict the future, to choose companies that I like to be involved in, I like to find out where that's happening. But when it comes down to it, it really comes back to the team of people that are actually building these things. At Hortonworks, look at Arun and Owen and Alan and Mahadev and Devaraj, and we had this team of founders that came out of Yahoo that had been doing this stuff, and yeah, they used MapReduce, and they took that paper, and Owen built that. Owen O'Malley, and he wrote HDFS and MapReduce, and yes, and that created a whole new world as well. So this is happening again, and Kubernetes is the same thing. Like these people, they have run systems at scale, and they understand the issues and the challenges. And while it may be difficult at first, eventually these things do get consumerized and they do get packaged and they do become easier over time. And I think that's I love to be at companies that help bring this sort of really complex technology to everybody. It comes back to like my heart is product marketing. I like to take complex topics and translate them, and the same sort of thing. It's been part of my career, and I love it. I'm just so happy that I've been able to do that. So it's fun.
Excellent. All right, let's see the results of the poll if we could. I'm eager to see how many. Look how many said geo-distributed, Jim. I thought that. I mean, it's not first place, but I thought it would be a more distant.
I got my mom on this and my two brothers.
You bought a few votes, did you? All right, but also
They're the only ones who didn't
Also,
say relational.
well, I was just going to get to that. I mean, no matter how much we're talking about new technology and new paradigms, look how many people are using, the trusty old RDBMS.
Yep.
Now, the question is, can we reconcile these things? Can they coexist? And I think it's obvious the answer is yes from our opinion, or we wouldn't be here talking about it. But I think that's super important to see that even as the new paradigms settle in, the old ones, they have their workloads that are assigned to them that are, keeping lights on and running things. And this was the thing that shocked me when I came to big data from enterprise BI, was just this notion that everybody was rejecting the older stuff, including SQL as a language, because at that point, NoSQL was less of a misnomer, and most of those databases did not support SQL as a query language. That just struck me as arrogant and silly. And I think we have, there's a middle ground, right? You can absolutely break out into bleeding edge stuff, and you may need to, and that does not negate what came before it.
Right.
End of
sometimes you just don't understand your own future. Look at, man, when NoSQL came out, I was like, I don't get it. Come on, guys, really? Like, what do you mean NoSQL? It's got to be SQL. You know what they did? I like Cassandra. Apache Cassandra, I think, is one of the most successful stories in NoSQL, and like how awesome it's running. I don't know if you're streaming something on Netflix, like half of their infrastructure is running Cassandra. It's awesome because they took the guardrails off a database for transactions, basically, and they say, great, how do I get data? And that's like, it's really cool that somebody thought to do that because they had that challenge. And what's wrong is, like, I think people are trying to get that scale of these kind of NoSQL things, but they lost the transaction side because, well, that's what was out. And we've come a long way. How do we add transactions back to that? And so I still think like the NoSQL databases have their space. And it was a great poll result because there was 36% us and 32% NoSQL, or what my world is. And I think that's indicative of what the future is going to look like in the not so distant future. You use the right tool for the right thing. So it's interesting.
Yep, indeed. And they're not mutually exclusive anyway. I have some anecdotal stuff for that, but I'm going to skip it now because I want to talk about Geo-Distribution there. So we did see a good significant chunk. Let's get specific about why this is important. Like, beyond the sort of loyalty vote of, of course it's important to be global and inclusive. And it's important for me to be ready when I have users or customers on another continent. But that seems kind of abstract. So there's some things in here where we try and get more specific, more concrete. Maybe take us through these either, point by point or just more generally, whatever you're most comfortable with.
Sure. And global is a funny term. It's one of these things like, look at everything's not global. And we touched on that at the very beginning, Andrew. You and I have had conversations about this, but what is actually true here across the board, or at least what I see in modern IT and modern infrastructure, is the distributed part of this. And being distributed means, you have nodes, or you're going to have instances that are running on different servers, and those servers can be on different racks, and those racks can be in different AZs, and those different AZs might or might not be in different regions, and those different regions might be in different parts of the globe. And so, like, it all builds on each other. And so, if you ultimately want to be global, well, you got to be able to distribute yourself across different racks in a single AZ. And so all these things are really important. And so when I think about Geo, I just think about being distributed in many different ways. And I think the benefits of actually designing something that is distributed allow you to do things like put data in front of a user no matter where they're at, right? Because I think, what we're seeing from our customers for sure is that, the latency, the time it takes for a transaction to happen, people are not going to accept anything under 100 milliseconds. It's just too long. And so how do you do that when, you have a user in Sydney, but your database is located in Raleigh because you have, a single instance database, or maybe, the right node is in, a data center that's in North Carolina. Like, it's just, I can't beat the speed of light, man. Like it's a problem. But I could distribute the data so that it actually lives in the right place, yet it's globally consistent. And that's the kind of stuff that having a distributed database, being geo-distributed allows you to do. We've implemented something really cool. And when I first learned about this, it just kind of blew my mind. In Cockroach, we've implemented something called geo-partitioning, which actually allows the database to take care of where data lives. We can tag every node, if you will, in the database, every instance. You could tag it as, Raleigh. You can tag it as Sydney. You can tag it as Germany. And the database itself and the design of the underlying storage layer is smart enough to understand that data that's been written to a particular region, say you're using the country field on your table in your address, right? All that data needs to live in, say, Germany. And the database is smart enough to actually deal with that. So you can better deal with, we designed it because of, if you're going to be distributed, well, performance is a really big thing, right? And latency, and I can't beat the speed of light. The other side of the outcome of this is people love it for compliance and jurisdiction of data, right? And so there's like this other huge, massive benefit. You don't have to do that in the application, man. Let the database do that so that all applications inherit that basic compliance capability. And people love us for that. Like, and it's and I think it's really important. Like when you think about a distributed database, when you design a database, 10, 15 years ago, you're just thinking about the DDL, right? You're just thinking about, okay, what are my tables and my indexes and secondary indexes, and what I'm going to have to accomplish with joins and all those different things, right? And that's still very important today. When you go distributed, you have to think about two other vectors and concerns. It's latency and resilience. Because data is living in different places, you want to be able to design it so that you can reduce latencies, or you want to survive failure. And since we can distribute database, distribute the data underneath, you get this distributed nature gives you this very natural resilience. And I think we're going to talk a little bit more about that when we talk about scale, but not thinking about having to deal with like 2 data centers and having an active passive system where I've got this huge instance of a super expensive database running twice, and when one of them fails, I have this failover, and I have this moment in time where I can't even take transactions, and then this other system is up, and then when that other system comes back online, the original one that was broken, how do I actually make sure that the two are aligned, and how do I remediate the different? Oh my God, what a nightmare that is. And being distributed allows you to shrink these kind of recovery points down to 0. Having a database that is active, and letting the database deal very naturally with this resilient nature as well. To me, that's really this fault tolerance stuff. That's what being distributed means. And it's geo because we can actually do that too, if that makes sense. I think I talked about it before there, right? Yeah.
The fault tolerance is, as a database guy back when, fault tolerance was always something that kind of scared me. Like I don't know if I can be ready to do that. I'd rather just sort of deal with the assumption of a single server in a single place and that being good enough. Don't talk about that. I'm not ready for it. Now it's about, well, you don't worry about it. This is about your vendor taking it on for you. So as the database architect or developer, you don't worry about that. You assume it. And that, that's always the mark of a platform getting better, is if the stuff that worried you becomes, built into the platform. Go ahead. I'm sorry.
Well, think about it. Like, you were a database architect, and that's a scary topic. Let's talk about this generational shift that we alluded to earlier in terms of like.
I wasn't, by the way. I was an app developer who liked talking about databases.
Well, at least you were.
That's why I was scared.
You were better than the average app developer who actually thought about that stuff. Like, and so fast forward to today, app developer is a wholly different term. Like, are they thinking about resilience? Like, we have basically taken some of these complex concepts that we built, like other tools, like, I don't know, Golden Gate and Rack for Oracle, like these super huge kind of crazy technologies to solve a problem. We're baking that into the technology, right? Let's take advantage of distributed systems. Let's take advantage of what Google and Microsoft and these large Netflixes and what they've learned about resilience, right? And they've baked it into their solutions because they have thousands and tens of thousands of developers that do that. Let's put that into the layer where it needs to be so that now it's a natural piece of what you're doing. And I'm thinking about data resilience now. I'm not thinking about, the server resilience. I'm thinking about my data being resilient. Let's bake that in. And now you're working, and that's what I mean. You have to think about that in your design of the database itself. And by the way, we can change that on the fly, right? You just alter table and it's going to move things around for you. The database is now automatically redistributing and dealing with the change of infrastructure. I open a new data center. What does that mean for me, right? And so I don't want to have to go in and do any of that as a developer. Like the database should just do that.
When you take the stuff that was blood, sweat, and tears and you make it something I can deal with, but declaratively
Yeah.
through configuration, that helps a lot. The book that I read in college in the 80s that was written in the 60s by Thomas Kuhn called The Structure of Scientific Revolutions, it's uncanny how it continues to apply to every new wave in the tech market. And the basic idea is that you start with a model that works, and it works basically in all cases, and then you start discovering cases where it doesn't work, and then you patch it. You come up with corollaries, you come up with workarounds, you come up with just exceptions and say, all right, it works in all cases except in this case, then you do that. And you could kind of argue that the original client server RDBMS, like that worked. And then when we had to kind of cluster things and we had to deal with the fault tolerance, like you were saying, with the active passive setup and having a warm spare, and having the skill sets to go with that, like that worked. That was okay. Well, in the simple case, we'll do this, and the more complicated case, we'll grin and bear it and pay for the extra expertise and whatnot. And then when the patches wear out and you just can't keep patching and you need a totally new approach that explains everything again, then you have the paradigm shift. That's where that term right. Paradigm shift comes from. It comes from that book. So we could continue to take the, symmetric multiprocessing single server database with redundant instances and make that work in the global case. And maybe we think we ought to because it's lower risk. We avoid replatforming, but there's costs involved in that there's egregious costs involved in that may be a little bit stealthy. So we tried to point out some of those things here.
Right.
So, and I got to imagine that the virus is making people a little bit more in touch with this idea that we can't keep patching the old way of doing things.
Right.
Eventually, you need a kick in the pants to get you kind of over the inertia of trying the new thing while we got the kick.
Right.
And I don't know. So maybe I've finished all your sentences before you started them here, but expound on this if you would, and tell us how maybe it's impacted your pipeline and your customer interest, your prospects' interests at
I think
Labs.
You're talking about I want to touch on one thing. You talk about the impact of the pandemic, and I think at the very beginning, we're hearing this kind of like, it's like feast and famine for us, where organizations are trying to retract and they're basically trying to think about their costs and this sort of thing. And I think some companies are making very difficult decisions around people and layoffs, and that's really tough stuff. But there's the IT department, who's always been squeezed to shrink cost, is I think it's going to be some tough times for a lot of organizations right now. And I think that's I'm concerned, and I'm concerned just for my peers and people, and how long is this going to go on, and what we're going to do. But I think it's had an indelible effect in terms of how people think about cost and what we're actually looking at. We've lived in this kind of bull market for, I don't know, gosh, man, it's over 10 years, and I think there's people I work with today who've never seen a downturn and don't know what it means to, have to shrink and be really, cost efficient. I think not cost effective, but cost efficient. And so, we have a lot of conversations with our customers around, what's the true cost of a database? And it could be a growth startup, or it could be an entrenched, insurer who's, staunch conservative, right? And it's because I don't think everybody really understands, especially as we move to the cloud, what the true cost is. And yeah, there's this software and hardware, right? There's the license of the database, there's servers, there's all the added stuff you have to add for disaster, HA and replication. There's the integration, which is another key piece. Like, how does this integrate with all my existing tools, right? And there's not just cost in terms of the conduit and the tech you need, there's cost in the resources you need to actually manage all that stuff. Who's actually coding and connecting all these things together, right? And as simple as an application can be, it's still there's complications, right? It's like, setting up Kafka to, run streams between different places. That's complex stuff, right? It's really good tech. We used to have to code that ourselves. We don't have to do that anymore, right? But there's this there's also a cost, from administering these things. Like, what does it cost to manage? What are my DBA costs to actually go deal with the database? What does the cost of downtime mean for people? What does it cost from my reputation if that's down? What are performance costs? What is cost versus performance? But then ultimately, it really comes back to people and how fast I can get to market with applications, or how many people is it going to take to actually manage these things. And I think if I look at, why customers are speaking to us and why they're looking at kind of these cloud databases, it's really across all of that stuff that they are interested in basically squeezing, right? And if you can squeeze across a lot of different places like that, can you actually start to drive down the costs and become much more cost efficient in terms of, what you're doing with your data? Because it's ultimately look at the database is probably, I don't, you tell me, Andrew. I would love to know stats on this. I mean, it is one of the most expensive pieces of within any IT budget because it's so critical, right? There's huge value in it. I mean, it's like the true value in any organization today, in my opinion, is the data that they own. And so that's the data. Well, what's that repository? And that's
Yep.
that's the database. And it's an expensive piece of technology, and it's not simple either, by the way. And so I think lots of organizations are looking at their databases and saying, how do I actually get more efficient here? They've already looked at cloud and said, I can get efficiencies there. Okay, let's just mix the words cloud and database together and say, how am I going to extract some further efficiencies as I go forward? Yet actually maybe gain some new capabilities, like we were just talking about in the previous section. Right?
Yep. Yeah. I mean, you say database is important. I mean, it's like it's everything. It's like well, we both live in New York City, so we may take exception to this, but it's like a car. Like, you can't get anywhere without it. Of course, here we can, but we're taking public transportation, or at least we did back in the days before physical distancing, and so that was more like car as a service in a sense. We still needed it. We still needed the transportation. We still do, even when I walk now. But you need a driver. Like, car doesn't drive itself,
right?
And if if it's the wrong kind, whatever, the analogy is about to give out. But look, let's just call it out here. You could take your Oracles, your SQL servers, your DB2s, your MySQLs, your Postgres's, and try and string a bunch of those servers together and make this work. And arguably, the cloud makes that easier. But is that the paradigm giving out? And is it time for a shift? And I guess some of that, Jim, will depend on where people have their customers and where they anticipate having their customers. And that is the subject of our second poll before we get to some discussion of analytics as our last topic. So we're interested, and by the way, there's no wrong answers here. If all your customers are domestic, so be it. We're not shaming you. We're not global shaming you. We want the data. We're selfish, and we go GigaOM. We're super interested in knowing this. Like, where Where are they? And by the way, it's not just a dichotomy between domestic and global, right? You could have folks in if you're in a U.S. company, you could also have customers in Canada and in Latin America, but you could also be fully global all the way to Europe and Asia and Africa. So we want to get some of that nuance here. Is it everywhere? Is it mostly here, but in a few other countries that are geographically distributed, or is the wherever you may be, is that the nucleus? And then you also have some customers in adjacent countries or territories. We would just like to know.
Andrew, tying off one thing on that scale thing and the cost of scale.
Yeah.
Again, coming back to this whole look at these large global scale companies have been through this, and so if you look at Facebook Messenger or even YouTube for that matter, those organizations there. I love you know me. I love open source, and so MySQL and Postgres, they're now holy wow, they're just amazing pieces of technology, right? And being built in the open. Where people struggled is scaling those things because sharding, right? And so if you're going to run 1,000 shards of a database, think about the management and the complexity involved in that. Not every organization can do that. Not every organization can have 100 people just to manage the sharding of a database because I need to get to some sort of scale. Sharding 3 shards, 4 shards is a nightmare. And so there's a very, very clear cost. And for us, let's just automate all that sharding craziness. There's no need to. It's one of these things. It's
a great architecture, but that's exactly the kind of plumbing that I don't want to do. I mean,
no way, man.
That's the vendor's job. Sorry. And when some of these databases went into the cloud, they had these crazy low restrictions on database size in their first iterations, and we'd complain about that, and the vendor, I won't say which vendor it was, would come back and say, well, we recommend a sharding pattern. And it was basically, well, if you need 3 times the capacity, spin up 3 instances of the service, and here's some sample code you can use to distribute your data across them. I'm like, what?
And you're gonna have to hire somebody, to do that too. The complexity of scale is crazy. Where the promise of scale on the cloud is one thing, the complexity of doing it was another. And that's why really true cloud native databases, they take that out. They just take that complexity out.
Right. Which is, by the time you're having everybody write their own thing to do something, that's exactly when it should be factored out and put in the platform. That's what platforms are for. Otherwise, we could write it all ourselves.
That's right.
Let's see.
Well,
all right.
Andrew, that's what Cockroach is for. But then again, I'm a homer.
All right. Maybe we could see results of the poll and get a sense of how people's customer bases distribute. Well, look at that. I mean, I imagine there's some self-selecting going on here in terms of who our audience is today, and and interest in the topic. But half are all over the world. All right, we're overselling this need. Then it's not a future need for lots and lots of people here. All customers domestic, only 7%. I would have guessed higher.
Me too.
Maybe I should have said most or all. But anyway, this is great. So then I think my only disappointment here is maybe some of the points we were making were already self-evident to a larger part of the audience than we made, or that I made an assumption of, but all good. All right, our last mini topic here, we've got about 5 or 6 minutes, is analytics. And the notion that your operational database can these days, and arguably should, have the ability to do some analytics on its own. I mean, after all, in the SQL language, that's kind of what group by is, right? It's the most fundamental kind of analytics is doing aggregation. But beyond that, if you're running your database in the cloud, then you've probably got infrastructure nearby where your data lake is and where some of your IoT or other streaming data is coming into. how can we get these things to be federated so that even if the operational database isn't doing the analytics, it is facilitating our ability to do analytics in near real time on neighboring platforms.
Yeah. Look at, man, like this is just, you got to fit into, like, we solved this problem. We've been solving this for the last 10, 15 years, right? And it's like, there was an entire market called OLAP that emerged, and there was OLTP because, well, those are two different things. Like what Netezza and Teradata did, you know, and going way back, there's a reason that database, why those data stores focused on what they did. They were optimized for what they wanted to accomplish. The operational database has its own place, and that's why there's a different category. And let's, you know, for us, we just want to be a really incredible operational database. But we want to integrate with the way that you integrate with your OLAP and data warehouses today. And that, you know, is it CDC as a best practice, and you're dumping data into, say, a Kafka sink, and maybe you're doing some analytics on it in real time and stream processing? Or is it dumping it into an S3 bucket where you're just running some analytics on top of it that way? Like, and so these kind of broad, larger business analytics should be taken care of by those tools. Now, we also understand that in a database, people do want to run basic analytics. They want to do things like, you know, I want to calculate at the end of the day how many widgets I sold, and there's no reason I have to go to, you know, some warehouse to do that. I mean, can I just query the transactional store to do so? And I think, yeah, those sort of transactions. And I think, you know, we've moved a little bit towards some analytical transactions in relational data stores over the past couple of years. You know, we implemented in Cockroach, you know, vectorized query so that we can actually do these sort of things. And if you're interested in like database technology, doing that sort of stuff. Now, doing those things in distributed environments is actually really difficult to do it right. You know, if you're gonna run analytics, you know, there's a reason why the Snowflakes of the world have come about, and it's because they figured out that they can actually use distributed environments to provide analytics, and you could run it all on the cloud. And remember, a lot of stuff we were doing in Hadoop was like, how do I use multiple different servers? That was all in a single data center, because I don't want to start moving data around and running like repeated queries across crazy amounts of data when it's distributed all over the planet. It's just not you just can't do it. It's not cost effective. The egress will kill you from the cloud costs, right? And so let's get the data in the right place. Let's do it in the right place. But if there are simple things we can do where we use kind of a map reduce kind of like a pattern to go run some simple analytics, that needs to be in the database. And to me, you know, that stuff doesn't go away. That's part and parcel what a transactional database needs to do. And I think it's like, I think we have solved this from a best practice architecture point of view, and I think in the cloud we're marrying a lot of those things today.
Indeed. And actually, that was one point when we were looking at all the virtues of geo-distribution database. There was geo-distributed database. There was one we didn't talk to, which was, you know, kind of an and also or a yeah but, which is that, yeah, these things are different. Yes, it's a paradigm shift, but when you have paradigm shifts, that doesn't mean you just completely reject where you came from before. So the ability to have a completely different kind of underlying platform, but take practitioners and their skill sets that were honed over the last decade or two or three, that's important too. And just because you want a database that distributes easily and runs in the cloud and handles all these, you know, scale on all these different axes, doesn't mean you have to reject a relational geometry in the SQL query language.
That's right.
That you've got. I mean, that's not cost efficient to do that. The whole point is a really good platform provides a migration path, both in terms of software, hardware on the one hand, but also skill sets and just conceptual understanding for the practitioners on the other. If it's an abrupt switch that makes you have to chuck out all your old skills and totally reskill, like that's a glib thing for maybe a younger generation that's running the startup behind these technologies to do and say, well, yeah, those older skill sets, they're not important anymore. but I would argue, and clearly I have a bias that given my age and stage, but I would argue that's never a good way to do business. You want to bring in new concepts and capabilities and provide an on-ramp for everybody
That's right.
who's been doing it a different way.
That's right.
So, all right, well, guess what? And I mentioned to you early, I love to be able to end right on time. We're at the top of the hour. I think we covered exactly everything we wanted to, especially with that little footnote at the end about skill sets. The hour went very quickly, as I expected it would. That's a compliment, by the way. I really enjoyed the conversation. Thank you for being our guest and our sponsor, Jim. And thanks to our audience for tuning in and giving us some really interesting data points from today's polls. I wish everyone a good rest of their morning, afternoon, or evening, as the case may be. For Giga-Ohm, this is Andrew Bruss signing off.